In this video, we are going to work at switching to vertex form by hand. We are going to use the completing the square process. This is an algebra intensive process, so we are going to limit the by hand algebra to only examples where a is equal to 1. Our strategy notes tell us to add or subtract the value b divided by 2 squared. So let's take a look at this. First off, I know that the standard form of the equation for a quadratic is y equals ax squared plus bx plus c. And so in my strategy here, the a is 1, and so matching that up, I can see that the term in front of the x squared, that coefficient is 1. Next, my strategy says add and subtract the quantity b divided by 2 squared. So I look where my b is, and the coefficient here is 4. So I'm going to calculate b over 2 quantity squared. So then b is 4, so 4 over 2 quantity squared. So doing the math, 4 divided by 2 is 2, 2 squared is indeed 4. So it says to both add and subtract that. I'm going to look at a little theory behind that, and then we will come back and do exactly what it says. So the goal for this problem is to switch to vertex form. And we have in our notes that vertex form is y equals a x minus h quantity squared plus k. And so the a is the same in both forms, and our a here is 1, which we know. In vertex form, we have a y equals. In standard form, we have a y equals. So this is a lot to think about. Normally, if I'm solving an equation, I want to add the same amount to both sides. So if I would do that, I would get y plus 4, adding the 4 that we calculated to the left, and I would get x squared plus 4x plus 11, and then I would have a plus 4. And we know that this is sound algebra because we've done the exact same thing of plus 4 on both sides. However, we don't really want y plus 4 equal to something, because if we have that, we would then have to do additional work to get this into the correct format where it's y equals. So if I now want to get y by itself, I would subtract 4 from both sides. These guys cancel, and I have y equals x squared plus 4x plus 11 plus 4 minus 4. Well, I can also see that the sequence that I have at the end, the plus 4 minus 4, is equivalent to 0. So the value of that is adding 0. And the value is adding 0, which doesn't change the right-hand side of the equation at all. So this is why we can have this direction that tells us to both add and subtract the value, because that's equivalent to adding in 0 or not changing the original equation. Now, strategy-wise, we want to be very strategic about where we put the plus 4 and the minus 4. So instead of having it look like it does here, I'm going to rewrite my equation. This is my original, what I was given, y equals x squared plus 4x. I'm going to leave some space, and then I have my plus 11. In my space, I am going to add in the 4. So this 4, remember that we calculated right here, I'm going to put plus 4. And then to keep the equation balanced, at the end, I will put minus 4. Why would I do it this way? Well, the process is called completing the square. And so what I have done is I have calculated this number 4, which will allow me to factor the first 3 terms, that trinomial. So we had factored before, and we said we need factors of C that add up to B. And this is where the process is super helpful, because up here where I did the process, 4 divided by 2 is 2. And so showing my work up here, this 2 that is inside that parenthesis is the number that will allow me to factor. So I'm going to rewrite y equals, factor is to take the trinomial and make it into 2 things that are multiplied together. So I factor the x squared to be x and x. And I factor the final 4, that part C, to be 2 plus 2, plus 2, plus 2. And then I can do the math at the back of this. So 11 minus 4 is plus 7. Taking this one step further, I notice that both of my factors are the same, so I can rewrite this as the quantity x plus 2 squared, or times itself, and then plus 7. And this is vertex form. In this form, matching up with our vertex form, I see that the value for h, there's always a sign change there, is -2. The value for k is 7. So that means that my vertex is -2, 7. I could very easily sketch the graph because we have a positive a value, so we know it is a concave up graph, and the vertex, the minimum point, is at -2, 7. I go over here to up 7. I won't count that out, I'll just make it approximate. And then I'm going to have a parabola shape because of the squared, and a concave up with that minimum point that we just calculated. So this is an example of the completing the square process. That idea of completing the square is figuring out the number that will allow you to factor. Your 2 factors, if you use this process, will always match so that you will have a factor squared. That's the whole point of completing the square. And then you will have vertex form. So we're going to wait till our next video to do the next problem, and we'll go through the entire process